Hi, welcome back to Circuits with Angel. Today we will do a demonstration on how Ohm's law applies in a practical circuit. We will also use a multimeter to help us find missing values and better understand Ohm's law, and how our tools, like a multimeter, are not just helpful, but essential in the world of electronics. Now, if you don't know what Ohm's law is, I suggest you go look at the video I made previously, before we start. But here it is anyways. Ohm's law is a simple formula that we can use to find missing values in circuit diagrams. It is named after German physicist George Ohm in 1827. Officially, Ohm's law formula is used to calculate the relationship between voltage, current, and resistance in an electrical circuit. Another thing you must know is how to use a multimeter. I also have a video on that. You need to watch that one for sure. The multimeter is basically the only real measuring tool in our hobby electronics kit. It'll take me too long to go through all the multimeter options, so take a look at the multimeter video. I go through all the options we will use in a step-by-step instructional video. You can find the link in the description. All of our experiments in this presentation are done in a series circuit. The constant values we will work with are voltage, current, and resistance. In a series circuit, voltage is equal to the sum of all the voltage loads in the circuit. Voltage total equals voltage 1 plus voltage 2 plus voltage 3. Current is exactly the same through any component in a circuit. Current total equals constant in all parts of the circuit. Resistance is equal to the sum of the individual resistances in the circuit. Resistance total equals R1 plus R2 plus R3. Today we will need a breadboard, 1 solid core jumper wire, 2 stranded core jumper wires, 1 multimeter, 2 multimeter leads, 4 LEDs, 1 LED strip, and a 6-volt power supply. Before we begin with our practical experiment, I cannot stress the importance of you making this circuit along with me. Watching me do it will not give you the same experience and understanding as you doing it yourself. Building the circuit using the multimeter, getting the measurement results, and understanding the experiment firsthand. So we are going to build a simple LED circuit. We are going to measure our power supply, pretending we don't already know the answer. We'll plug in our ports, 200 milliamps and common. Then we are going to put the setting on the multimeter to 20 volts. The other setting goes to 2 volts, and we can tell that we have more than that since each battery has 1.5 volts in it, and we have 4 1.5 batteries. It is 6.3 volts. These are fresh batteries, so they have a bit more charge in them. We will round that to just 6 volts. Now we get building our circuit. First, we take our LED. Well, not exactly. First, we have to plug in our power supply. Now remember, black goes to blue and red goes to red. The long leg goes to the positive rail, to an empty row. We take our jumper wire next, connecting the LED's row to another empty row across it. Make sure the jumper wire is connected to the LED's leg, or else this circuit will not work. The last component we need is a resistor. We must go through some resistors to find the perfect resistance for the LED. Here's the 1 mega ohm. I really doubt this will work. It's 1 million ohms. That's what mega ohm stands for. It doesn't turn on, but it's 1 million ohms. Let's try the 470k ohm. It's about half of the 1 mega ohm. I think one that would actually work would be the 27k ohm. It also doesn't work. Alright, let's move to the 27k ohm. It's probably going to be very, very dim if it even turns on at all. The 27k ohm is way too dim, though it does turn on. Let's try the 1.2k ohm. This one should work really good because it's close to 470. The 1.2 is signed very bright. We will be using that. We can write that down on a page I will get in a second after we measure current. Now we must measure current. We plug the multimeter to 200 milliamps and common port. It's going to stay like that for the rest of the video, so you might want to keep that there. We turn the dial to 20 milliamps since there shouldn't be much current. We're going to become the jump wire using our multimeter as the connection. We take out the jump wire and we replace it with two of our own jump wires, linking the components together. And after we've done that, we can go take our leads and touch them to the multimeter leads. Make sure your jump wires are connected to the components, otherwise you won't get a measurement when you touch the leads. When you touch your leads to the jump wire, make sure that you're holding onto it for 3 seconds or more. Otherwise, you won't get an accurate reading and your numbers will be all over the place. Alright, I'm pretty sure this is 4.2 milliamps. Alright, now that we have our measurement, we write it down on this page. I forgot to write resistance, so I'll write that down too. There are some schematic symbols on this page. There's an LED, a resistor, and a power supply. I have a video on schematic symbols that you can check out too. Alright, so we're just going to write down our resistance really quick. Man, I always seem to forget to write down the ohm symbol. But don't worry, I'll write it down in a second. Now it's time to write down amps. Now remember, amps are constant in all parts of a circuit in a series circuit. So we're just going to write down 4.2 milliamps in every amps section. And if you can't read what my sheet says in the top left corner, it says a milliamp is 0.001 of an amp. An example is 9 milliamps is 0.009 amps. Right now, I'm writing down 4.2 milliamps as an amp, which is 0.0042 amps. Oh, and we have to write 1.2 k ohms as 1,200 ohms because a k equals 1,000, and that's 1,200. Now you may be wondering how I get such a small number. Well, we go 4.2, because that's the milliamps, and times 0.001, because that's where the thousands place is, and that's where milliamps is. And that's how I got the number. You can do this with any number of milliamps, but I just wanted to demonstrate how I did that. Alright, let's actually get calculating. So for voltage, we have to go resistance times amperage. So 1,200 times 0.0042 equals 5.04 volts. So that's the amount of voltage in the resistor. But to find the voltage in the LED, we have to take the power supply voltage and minus the resistor's voltage. So 6 minus 5.04 equals 0.96 volts. And that's the amount of voltage in the LED. And that's how we're going to be calculating voltage in this video. And now all we have to do is write that down, and we're going to be done with this worksheet. And then we can move on to the other two. Yes, the other two. We're going to be doing two more experiments to make sure we have the hang of this. In the next experiment, we'll be using light strips. I really like using light strips, so this should be fun. And ta-da! We are done our worksheet. Here I have an LED strip. I use these as lights for plants. My mom is really into gardening, and she bought a grow lamp that had LEDs to start her plants inside. But now she wants me to make her own LED grow lamp using these light strips as an experiment. This is something I'm playing with right now. I hope to make a video about it eventually, when I get it to work. We're going to continue using our 6-volt power supply. We have the same resistors to test as last time. This 1 mega ohm resistor does not work. So we set up using our LED strip, and we put the positive leg of that to the positive rail and the other side to an empty row near the negative rail. The 470k resistor The 27 k ohm should work pretty well. Or apparently not, even though this is more than 100,000 less ohms in it. Let us try the 1.2 k ohm resistor. It works good, but it's not as bright as I would like it to be. I know this isn't bright enough. It seems we are left with the 470 ohm resistor. I need it more lower than this. The resistor gets hot over time and melts holes into the breadboard, which is not good. I'll talk more about that in a minute. But still, the 470 ohm works pretty good. It's still pretty bright. And that's our resistor value. Now let's move on. But I'd like to talk about the LED strips for a minute. The LED strip is basically a bunch of LEDs in series. Series is when electrical components are connected to each other, so they're all like one row getting voltage from one to the other. In a parallel circuit, they all get current from the same source, but independent of each other. That's a parallel circuit. I'll go into that later, but for now, this one is about a series circuit. The LED strip can be brighter, but we need a lower resistance. If it gets any lower than this, the resistor gets hot over time. And if it gets too hot, it could burn out or melt our breadboard holes, which is way more likely. And that's dangerous, so always remember, safety first. Alright, now we gotta measure our current so we can find out the voltage. I unplugged my ports so we can do it again, just so you know how to plug it in. So we plug in our ports to 200 milliamps and common. By the way, if your multimeter isn't working, make sure your leads are pressed down into the thing. You can't just have it just on top of it, or else it won't make a proper connection. And turn the settings to 20 milliamps, and after that, we get to move our jumper wire into an empty row in the breadboard of our LED strip and replace it with two other jumper wires that will connect to our multimeter leads. Now, we always gotta make sure that our components are in the same line as our jumper wires before we go. So make sure to check that. Alright, now we're gonna touch our leads. Alright, so I'm gonna say that's 7 milliamps, and we're gonna go write that down. That was a bit quick, but I'm pretty sure it's 7 milliamps. I don't know the actual schematic symbol for an LED strip, so I just made a square with LED strip inside it because I don't know the schematic symbol. I even googled it and I didn't see anything. Anyway, let's continue writing that down. Alright, now that that's filled out, we can go to the calculator and calculate our values for voltage. Okay, voltage is resistance times amperage. So 470 times 0.007 equals 3.29 volts. Now all we gotta do is 6 minus 3.29, and that equals 2.71. But before we go, I'd like to say why we do this. So voltage equals all the voltage loads in the circuit added together. So if we take the power supply and minus one value from it, we should get the other value. Okay, maybe that took a while, but we're almost done our worksheet. And ta-da! LED strips take very little current. They're pretty cool. I can't wait until I get this grow lamp working properly when I start to work on it. This strip is actually supposed to run on 5 volts from the spec sheet, but as you can see, it does pretty good on lower voltages as well because I got a shorter strip. Our last experiment is what happens when we put 3 normal LEDs in series. Now, you may be wondering how to do this, because I spent a good few hours until my dad came and helped me figure out how to do this, after he showed me a video on YouTube on how to do this. But I'll show you. We are using a 470 ohm resistor because, well, as you may already know by now, that's the one I would have picked anyways, because I like the 470 ohm with my LEDs. Okay, to start our series circuit, we must put in the negative leg to the jumper wires row and the positive leg to an empty row on the breadboard. Then we take our second LED. The negative leg of this LED goes to the positive leg of the first LED we put in. And the positive leg of this LED, which we'll call LED 2, goes into another empty row across the breadboard because the next one has to go into the positive rail. And for our third LED, LED 3, we take its negative leg and put it to the positive leg of LED 2, and we take LED 3's positive leg and we put it into the positive rail. If you don't understand anything, just back up and you can watch it all over again. Okay, so right now we're measuring current. We're using the 200 milliamps port and the common port, and the setting we're using is 20 milliamps. So the first step to doing this, we have to take out the solid core jump wire and replace it with our stranded core jump wire, or our long jump wires. Okay, now I gotta make sure that you know that the jumper wires are supposed to connect to the components, or else this won't work. So if it isn't working, make sure that things are connected. Alright, now we touch our leads to the jumper wires. If your reading turns out negative on your multimeter, switch your leads around and connect them again. It should work properly now. I thought I'd say that because I was a bit confused when that happened at first too. But anyway, the amount of amps in here is 1.16 milliamps. I had to switch out my pen because the black pen was too thick to write in these small bars. When you get your worksheet, the bars will be bigger. This is just my first copy. Anyway, we're almost done all your sheets, so just hang in there while we finish doing our calculations. This is taking a bit longer than usual because 1.16 milliamps is a bit long to write. Oh, and the amps version of this is 0.00116. It's a very small number. Okay, we're moving on to the calculator. Alright, so voltage is resistance times amperage. 470 times 0.00116 equals, and that equals 0.5452. Alright, so now we're moving on to the LED's voltage. So we go 6 minus 0.5452, and that equals 5.4548. And then we divide that by 3 because we have 3 LEDs. And the answer is 1.8182 for each LED. Alright, so we're just going to write that down, 0.5452 volts. There's a lot of decimal points in this one. Now let's get writing down the LED's voltage. This is the last thing we need to do. So after this, there are no more worksheets or experiments. It seems that I've forgotten to put a V for voltage on those. Anyways, after this video, I'll probably be making a parallel circuit one, so you might want to keep an eye on that. Now that's how we find values in a circuit with Ohm's law. This took a while to make too, as at first I did not know how to do this. I hope I explained this well. You can send me an email at my website at www.circuitswithangel.com. Feel free to send me an email to flame me about how I do this. I'll welcome the feedback. I want to add my final 3 points card about this video. I haven't done that in a while. 1. In a series circuit, voltage supply is equal to the sum of all the voltage loads in the circuit. 2. Current is exactly the same through any component in a series circuit. 3. Resistance is equal to the sum of the individual resistances in the circuit. Thank you for watching and see you next time.